Okay, good evening, all of you, and let me know. Can you hear me? Hello, Kattira.
Yes, sir.
කියන්නේ පණිවිඩය දීලා කරපිට සංකව තමයි අල්ලගන්න ඕනේ නිදිමත හිතන කට්ටියට. හ්ම්. හරි හරි. අවුලක් නැහැ මේ so today uh, we have a very small part and also a very simple one. Um, in that part, we want to know how we can use the Kana map for simplify the Boolean expressions. ඒක අර ලොකු පාර්ට් එකක් නෙමෙයි පොඩි ඉක්මනට අපි කරන්න පුළුවන් පාර්ට් එකක් කොහොමද කාන මැප් එක අඳින්නේ කියලා. ඇත්තටම මේ කලින් පාර්ට් එකේ කොටසක්. හැබැයි මම පොඩ්ඩක් තිබ්බේ අර ඔයාලට බූලියන් එක්ස්ප්‍රෙෂන්ස් චුට්ටක් ඔලුවට දාගන්න ඕන හින්දා සහ ලොජික් ගේට්ස් පොඩ්ඩක් මොනවද කියලා දැනගන්න ඕන හින්දා. ඒක පොඩ්ඩක් මතක් කරගන්න. හරි. It's okay. Now let's move on to the Kahn parts. And there first, now there are many methods for simplification of Boolean functions. That the first one is method of the Boolean algebra, and that Boolean algebra part I have done in the last lecture, and you can remember the algebra and as well as the identities that you can use to simplify the Boolean functions. And today we are going to discuss about the method of Kana maps. And normally we do not use the method of computation because normally it is somewhat complex as well as so therefore we are using it for the inputs more than for 5 inputs. Actually, that we can use it for uh, 2 or 3 inputs as well, but it is too much complex. So, by using a simplification methods that we only have to simplify the things, not to make them complex. Okay. So the first thing that you should know what is a Kahneman. So, sorry. Kahneman is normally a diagram which presents all possible outputs. Actually, not all possible outputs because outputs can be 0 and 1, but all the outputs for the possible combinations of inputs. So, wait, I will draw. Can you see that what I'm drawing?
Yes,
Can you
sir, we
see?
can.
Yes, that's okay. Okay. Here you can see here you can see the Kana map, and this Kana map is of 16 cages. So normally, in a truth table, uh, that we have rows. So there are the input A. Uh, straight. Uh, I think you cannot see my drawing, no?
Now we can't see.
Yes. Uh, there is some problem in the drawing pad. Uh, no matter. And you can see the things. There are explanation of the combinations around this corner map. So here you can see the inputs A and B. So as there are two inputs, there are four combinations that we can have. Uh, here the combinations 0, 0, 0, 1, 1, 1, and 1, 0. It's present horizontally and the vertically that you can see the combination from of the CD. So therefore, overall, as there are four uh, inputs, there should be 16 possible outputs. The possible combinations of inputs. So therefore, according to that, there will be 60 corresponding outputs. දැන් ඉන්පුට් කෙලින්ම හතරක් තියෙනවා. ඒ හතර අපිට කම්බිනේෂන්ස් විදියට ගන්න පුළුවන් ඒ කියන්නේ ඉන්පුට්ස් හතරක් හින්දා ඉන්පුට් කම්බිනේෂන්ස් 16ක් ගන්න පුළුවන්. ඒ 16ට අදාළව කොරස්පොන්ඩින් අවුට්පුට්ස් 16ක් ගන්න පුළුවන්. So I think you got it. Okay. Now I think you can see the drawings. Okay. So by looking at any cage here, these are not rows or columns. In a corner map, there are cages. So this cage present the output A, B, C, D, and there you can see A is 0, the B is 1, yeah, and C and D both are 1. So by this 0, that's mean if the output combinations are like this 0, 1, 1, 1, so the output is 0. So if you take this cage and there you can see the A, B are all true and C, D are false. So on that case, the output is 1. So like that, we can identify what is the corresponding output to a possible input. So in that case that you can see uh, in a truth table, that's normally if there are two inputs, how we draw it is start from 0, 0, 0, 1, 1, 0, and 1, 1. But in this one, you can see when you go horizontal in horizontal direction or vertical direction, always only one bit change. So therefore, in this case, think from if you go from 1 to 2, sorry, 0 to 1, only one bit change. But when we are going from 1 to 2, this first bit also change and also the second bit change. But in this case that you can see, always only one bit change. 0, 0, 0, 1. Then only this bit change to 1. And the second one remains without any change. So like that, we draw the corner maps. So then what we have to remember, the adjacent cells, these cages or cells, differ by only one bit. Even at the end. So because you should know this cell is connected with here, this cell. So therefore what you can see, when here it's 1, 0, the rightmost cell, and the leftmost cell is 0, 0. When you are going in this side, so you should know this is connected, the rightmost side is connected with the leftmost side as well. So therefore, in those edges, the bit is only changed by one. Only one bit change. You can see here 1, 0. Then this 0 remains constant, but only this one is changed. And then you should know this upmost edge also connected with this bottom of the carnival. So therefore, you can see even in this side, the CD 1, 0, and it is connected with this one. So therefore, only one bit change. So this is how we can draw a carnival. So please raise your hand if you do not get this. මේක තේරිච්ච නැති කට්ටිය ඉන්නවා තුස්. කානමැප් එක අඳින විදිය ගැන. මොනවාරි ප්‍රශ්න තියෙනවා අහන්න. මොකද මේ දැන් මොක මේ පුළුවන් කරගෙන එතන නිකන් ආයේ බොරුවට ටයිම් එකක් ගන්න ඕනේ නැහනේ. Because this is a very simple thing. So therefore, just remember and practice with me. So okay, that's mean that no one has any problem. So therefore, I move to the next part. Then let's see the structure of the carnival. So in the first image, so in this one, this slide, that you can see a carnival of 4 variables or 4 inputs. So therefore, this can see as there are as you can have 4 various combinations. Sorry, 16 combinations for 4 inputs. So therefore, you will have a cage or carnival with 4 by 4 cells. That means 16 cells. If there are only 2, there are only 4 cells in the corner map. If there are n inputs, so that means there are only 2 to the power n cells in the corner map. So you can see if there are 3 inputs, 2 to the power 3, 8 cells are in the corner map. So in that case that you can see, normally in the truth table that we are number them from like 1 to 0, 1, 2, 3, 4, like that. But as we have conditions that each adjacent cell should change only one bit, you can remember the adjacent cells differ by only one bit. So therefore, what's happened? This order is changed a little. So 0, 1, 2, 3, 4, 5, 6, 7, like that. Mm. So in this one in the card map with 16 cells, you can see 0, 1, 2 is at the end, 3, 4, 5, 6, 7, like that. Okay, now you know how to draw. Now you know what is the structure of the Carnot map, and now you know how to draw a Carnot map. So let's move. So the purpose of this Carnot maps is, the main thing is simplify the Boolean expressions, and therefore it's used to reduce the number of logic gates. The Boolean expressions, by the Boolean expressions that we can draw the logic circuits, and therefore we can reduce the number of logic gates, and so therefore that it's used to minimize the hardware complexity, because by reducing the logic gates, it causes the minimizing the hardware complexity. And also as there are few laser units, so it's improves the circuit reliability and the speed. So these key features that we have discussed, and let's move on to what are the rules in drawing the Carnot map. So normally in Carnot maps that we use 0 and 1. In some cases that we use X, I will explain it later. But here normally that we draw a Carnot map like this, and these each cell represent output, and we have to group the ones. So you can see here ones are 4 ones. So therefore we have to group them. So this grouping has a method. So those are the rules of the Carnot map. So the first thing, when you are grouping the ones in a Carnot map, any group may not include a cell with 0. So you can see here in this one, this grouping contains a 0. But a grouping like this, it does not contain a 0 cell. So therefore, this is the right way. And the groups may be horizontal or vertical, but not diagonal. So you can see if the inputs once are placed diagonally in the Carnot map. So in this case, you cannot group them. So therefore, if you want to group them, that you have to make groups with one cells. And in this grouping, that you should remember that you can only group in the cells into the powers of 2. So 2 to the power n groups can be made by you. But in this case that you should know, so here we can use one cell because it is 2 to the power 0. It's equal to 1. Otherwise, that you have to make the groups with the powers of 2. Okay, this thing that I have mentioned. So in this case that you can see, uh, you can make groups like this, and so this is a group with two cells, but you should follow this one. Every group contains 2 to the power n's, 2 to the power n cells. So therefore, you cannot group 3. So therefore, in this case, how you can group this kind of Carnival? So you can select these two, and as well as you can select these two. So the groups can be overlap, but always you have to follow this rule. And here 4. So this is right. And but in this case that you can see that you have grouped 8 mm, inputs, but according to this rule, it is no problem, because you can see this group covers 8 cells, but you know that you cannot group the cells which contain zeros. So therefore, how you can group this kind of Carnival? So select this kind of a Carnival that we can select the groups with two cells. Here two cells, two cells, two cells. Actually, this is not wrong, but know our purpose is to minimize or simplify the Boolean expression. So therefore, for in that case, that each group should be large as possible. So here you can see even in this uh, kind of corner maps that you can draw one group of these 4 cells and one group of these 2 cells. But this is also not correct, because I told you the groups can be overlap. So therefore, no matter, use the overlapping groups, no problem with the overlap. So therefore, that you have to group large as is possible. So therefore, what's happened? The better one is group these 4 and then group these 4. These two cells are in both groups, but that's not a problem. In that case, this uh, the simplification happens very effectively. Okay. So let's move to the next part. Uh, each cell containing a 1 must be in at least a one group. So therefore, that means the we cannot avoid A's. Sorry, we cannot avoid ones. So if there is any one, whether it is along, we have to to select it as a group, even a group with one cell. Actually, now tell me if this grouping is correct. මේ grouping කරලා තියෙන විදිය හරිද වැරදිද? Please tell me. It is correct no matter, but don't we have can't we simplify this anymore? That means can't we draw a large group more than this? මීට ලොකු group එකක් අඳින්න පුළුවන්ද බැයිද? You can so you can see in here there are two groups, group one and group two. So you can select it as a single cell, but it is better to select like this with two cells. So in this case, again, it's mentioned about the overlapping is true, overlapping of groups. So the overlapping of those groups can happen. So I have mentioned it earlier. So now let's move to the next rule. Uh, this one also I have mentioned the leftmost cell and the uh, leftmost cell and the rightmost cell also connected, as well as the top cells and the bottom cells are connected. So that's mean we can draw groups containing the edges. Uh, so that's mean if we think that if we have a concept like this, I make this both zero. And this is one, and this is one. So in this case, that you can see that you can group considering the connection of the top cells and the bottom cells, as well as the leftmost cells and the rightmost cells. So here how you can see, you can draw a group like this. So containing these two and containing these two. So you can understand. So here it's contain a group of four ones. So it's like one, 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 one. Got it? And also you can group these two. This one with this one. It is a group containing two ones. So like that you can make groups, because you should know that these groups wraps around this table. Okay. Mm, the next rule is you can have few possible groups. So therefore, but give me 1 minute. Uh, okay, let's continue. Uh, so, so there can be few groups, and they can be overlap. But this all these groups should follow the rules that we have discussed earlier. Okay. Now let's move on to the steps in minimization. So I have mentioned these steps. And then before that one, I want to tell you what is represented by this X. So there can be don't care and can't happen situation. So in some cases, the output can be 0 or 1. That means it's do not care input. So we can use it as 0 or 1. So in these cases, in the Karnaugh map, that we use the mark X, the cross marks, to represent this don't care term. And also there can be can't happen terms. So those are also marked as X or with the cross sign. So that means they can never occur physically or logically. It means that they cannot happen. දැන් ඩෝන් කෑ එක ගත්තොත් එහෙම එයාගේ ඉන්පුට් එක මොන වුණත් එයාගෙන් එන අවුට්පුට් එක අපි 0 වෙන්නත් පුළුවන් 1 වෙන්නත් පුළුවන් ඒක ප්‍රශ්නයක් නෑ. එතකොට වෙන්න පුළුවන් ඒක වෙනස් වෙන්න පුළුවන්. එතකොට අපි ආව x කියලා මාක් කරගන්නවා. කාන්ට් හැමට එකක් වෙන්න බැරි එකක් තිබ්බොත්. දැන් ඉන්පුට්ස් තියෙන්නේ 8යි කියලා මේ සෝරි ඉන්පුට්ස් තියෙන්නේ 3යි ඒ කියන්නේ කම්බිනේෂන්ස් ඔක්කොම 8යි. අපේ තියෙන කාන මැප් එක සෙල්ස් 16 කාන මැප් එක. එහෙනම් ඉතින් 8න් පස්සේ තියෙන කම්බිනේෂන්ස් වෙන්න බෑනේ. ආයෙ ඒ වගේ වෙලාවට අපි ක්‍රොස් මාක් එකෙන් x වලින් එකම ටික මාක් කරලා දානවා. Okay. So in Karnaugh maps, both these conditions marks as S, and they can used in groups or we can ignore. ඕනනම් අපිට x තියෙනවා අතහැරලා දාන්නත් පුළුවන්. අපිට group හදන්න ලේසි වෙනවා x ගන්නත් පුළුවන්. නිකන් x නිකන් අපේ වාසියට පාවිච්චි කරන්න. So you can see by using we can use the x term to simplify the logics. So if it makes the expression more complex, that we can ignore. But if we these x terms, then we have to include them in grouping. So I think you got this. Then you have to follow these steps in minimization. So that means steps that we are used to minimize the expression. So these things I have mentioned. So therefore, let's go to the example. Okay, so please all of you write this question and draw the corresponding truth table. හරි. දැන් කට්ටිය මතක තියෙන එක. එහෙනම් f again for f of abc is equal to the f of abc is the sum of min terms 0, 1, 3, 5 and 7. So therefore draw the truth table. හරි. දැන් කට්ටිය නම් මේ ගාන ලියාගෙන ට්‍රුත් ටේබල් එක අඳිමු. Now you should know this is one type of a question that you can find in the exam. The exam එකට set වෙන මේ වගේ problems. හරි. continue කරමු. Okay, now you can draw it with me. So here A, B, C, and F. So what's happened? So by this, it's represent 1, sorry, 0, 1, 2, 3, 4, 5, 6, and 7. So the this is the sum of min terms. So therefore 0, 1, 3, 5, and 7 are the ones. 0, 1, 3, 5, and 7 are the ones. And others are 0. So now write the Boolean expression. So before that, I will show how we can do it with the Khan maps. Then at the end, let's see how we can use the Boolean expressions in solving this problem. Okay. So now for this case that we have to draw a Khan map. So I will draw it. The Khan map should have weight cells. Here I use AB and here C. So let's take 0, 0, 0, 1, uh, 1, 1, and 1, 0. In here 0 and 1. So therefore what's happened? Now I'm going to read the values. So 0, 0, 0, it's 1. And 0, 0, 1, 0, 0, 1 also 1. And 0, 1, 1, 0, 1, 1 also 1. And 1, 0, 1. 1, 0, 1 also 1. And then the final one, 1, 1, 1. It's also, we can keep it in to the corner like this. So then others will be zeros. And now that you have to do the grouping. Now the grouping is little easy here. So what you have to do, that you can groups like this. There is you can only get two and two cells to this group. And there is also another group. You can draw like this. Okay. Let's take this group as group A and this group as group B. Okay. When you consider these two cells, now tell me, when you consider these two cells, what are the inputs that they does not change? දැන් මේ cells දෙක ගත්තට පස්සේ දැන් හැම cell එකකින්ම identical input combination එකක් පෙන්වනවානේ. හැබැයි මෙන්න මේ cells දෙක ගත්තට පස්සේ මොන input එකද වෙනස් වෙලා නැත්තේ? So you can see in these both cells, the 0 and 1 has changed. So C input has changed because in here it is 0 and here it is 1. මේ C ගත්තොත් එමේ මොන වෙනස් වෙලා තියෙන්නේ පේනවනේ. C මේ cell එකේදී බිඳුවයි මේ cell එකේදී 1යි. හැබැයි මේ group එකම ගත්තට පස්සේ A B කියන දෙක වෙනස් වෙලා නැහැ නේද? AB මේ cell එක ගත්තත් AB කියන්නේ A0 B0. මේ cell එක this AB is not changed and they are remains as 0. But you know, in this case that we have to convert them to 1. So therefore, by the group A that we can get the output. Now we are going to express it in Boolean. So therefore, what's happened? The output, we can write it with the unchanging inputs. That means the inputs are constant in a group. So this, you know, the A and B, but in this case, A and B are 0. So therefore, what you have to write? A dash, B dash. And this is from group A. So the next group, we have to add this, the next group for this output. So it is the group B with 4 cells. So tell me what is the unchanged input in these 4 cells? So what is the input that does not change inside this group? මේ group එකේ එක cell එකවත් වෙනස් වෙලා නැත්තේ මොන term එකද? මොන input එකද? Tell me. Yes, it's C. So therefore it's C. So actually, this is the simplification from the Kahneman. Got it? This is how we can simplify using the Kahneman. ඔන්න පේනවනේ කෙලින්ම Kahneman එක මෙන්න මේ තරම් ලේසි කරලා ගත්තා ඒක. හරි. Let's see if we do it with Boolean expression algebra. හරි. අපි බලමු දැන් is sum of min terms ලියලා. So this is not with the Kahneman. This is Boolean algebra. And with sum of products. So here what you have to do, you have to select 1, 2, 3, 4, 5. You have to select all those combinations. Here first one, 0, 0, 0 means A dash, B dash, C dash, plus the next one, A dash, B dash, C. Here, here you can see C is 1. And then there should be 5 product terms, that means min terms. The next one, A dash, B, C. Next, A, B dash, C. This one, A, B dash, C A B dash C plus the last one A B C. So let's see when we are simplifying this one. So I can see the C in these two terms. So I'll come from in the reverse direction. When I select these two and select these two in separately. So oh, no matter I can uh, select in any direction. Uh, okay, I'll start in from left to right. හරි මම පටේ පැටලේ නම් මම left to right පටන් ගන්නකො. So you can see, you can write it A dash B dash. Those are common for these two tabs. So therefore you can get C dash plus C out. And again what you can do, plus C, and you have these three terms. A dash BC plus A B dash C plus ABC. And here you know this one, and so you can write it B dash. I do not write the rules here, but you should write the rules. Okay. Uh, when you are simplifying it, because I just want to show you how you can do this simplification. So here you can see another two common terms in this dash B C plus in these two terms contains A and C. And A, so there you keep B plus B dash. So B dash plus B here. By using these two terms. So therefore, what's the one? So this is also one. Then you have F is equal A dash B dash plus A dash dot B C plus A C. So what you can do is what? A dash B dash plus you get C out of. Actually, I am doing the commutative law without using a line here. දැන් මම අර commutative law එකේම මේ ප්‍රශ්නයක් දාලා තිනවා ඕකට පොදු පදේ ඇඩ් කරගත්තා නම් ලීසි නේද කියලා. ඔව් මේ ඒක හරි. මම මේ ඔයාලට මුකුත් පොදු පද පිටින් ඇඩ් කරගන්න නැතුව කෙලින්ම මේ කියන්නේ මේ තියෙන එක්ස්ප්‍රෙෂන් එක සිම්ප්ලිෆයි කරගෙන යන්න විදිය තමයි පෙන්නන්නේ. නැත්නම් අපිට වෙනම ආදේශයක් ගෙනල්ලා මේක තවත් ලීසි කරන්න පුළුවන්. But this is how you can see it. මේක මම මේ පෙන්නන්නේ ඔයාලට කොහොමද ඒක පේන විදිය කියලා. ඒක මම රිවර්ස් එක නැතුව කෙලින්ම left side and right side එකම හදාගෙන යනවා කියලා. හරි. ඔව් මම කිව්වේ මේ commutative law එක මම ඉතින් මේකේ මෙන්ෂන් කරන්නේ නැහැ. වෙන පාවිච්චි කරගෙන යනවා. So here you can see into A dash B plus A. So now what you can do is you can use the distributive law. Uh, A dash B dash plus C here, and inside this you can use uh, the distributive law. A. Another one is A plus B. So got it. So here again one. Uh, and yes, actually, by this part, it's getting much complex. මේක අපි මේ විදිහටම යූස් කරන් ගියොත් එහෙම මෑ ටිකක් කම්ප්ලෙක්ස් වෙනවා තමා. ටක් එහා මෙහා අමාරු කරගන්න එක ලේසි. ම්ම් Okay, I will show how to make it more simple. මේක මෙතන යන්න ඉඩ මදි වෙනවා එතකොට. මේක so actually that you have to select this one as one. Again, you have to do some uh, more steps. But at the first sight, I saw direction. මාර කලින් කිව්වාගේ reverse direction එකෙන් පටන් ගන්න. මොකද මේ කරන් යද්දී නැත්තම් තව ටිකක් දුරට යනවා. එතකොට අපෝ අපිට substitution use කරන්න වෙනවා. ඒක හින්දා normally මෙන්න මේ මම මේක reverse direction from right to left කරන් එන්න. එතකොට lazy. Actually, this is not wrong. That means it's not incorrect. This is also correct, but this make it one more complex. And one of student that have mentioned it 22T 1036 that it's that you are correct. And okay, I'll use it from other direction. So here you can write it like this: F is equal no matter A dash B dash C dash plus I will take it here A B C, because actually what I am doing here want to do the simplification. Using this kind of order. මේ normal අපිට තියෙන lazy order එකට තියන් ගියාම පුළුවන් දැන් මේ ABC වගේ තියෙන එක මේ complement වලින් කරන් යනකොට වඩා සුළු කිරීම කරන lazy. ඒකයි මම මේ ඉස්සරහට ගන්නේ. Then I will get A dash BC. Why I get it here? Then by these two terms, I can easily eliminate A dash and have B, eliminate the input A and have BC. Or if you like, You can use this term. කවුරු හරි කැමති නම් හරි අපි එහෙම නිකන් කරන්නම්කෝ. You can use the ABC with this term. So here what's happened? A, B, C, AC, B dash. So again, like these terms, you can get A dash and C with B dash. Again, it comes a little bit more complex. Uh, Here I use AC plus B plus B dash, and here again A dash C use for. Okay, then you can see here I eliminate avoid this part, and I am simplifying with this using these four terms. So therefore, what you can see here, this one is 1 and this one is 1. So by this part, you can get A dash, B dash, C dash plus here AC plus by this one A dash C. Put it here A dash C. And then again what you can do, A dash, B dash, C dash plus you can get C as the common term out. Then here you get A plus A dash. And here it is again 1. So by this one you have F A dash, B dash, C dash plus C. But you know that you can simplify it up to this. So therefore what you can see. Actually in sometimes that you think that you have to stop from here. මෙතනින් නවතින්න ඉතින්. හැබැයි අතන බලුවොත් අපිට මෙතෙන්ට නිකන් සූ කරන්න පුළුවන්. මොකද කාන මැප්පෙන් සූ කරන්න පුළුවන් කියන්නේ මේකෙන් සූ කරන්නත් පුළුවන්. හරි. Let's see how we can do it. So again I will change using the commutative law. I will like it like this. A dash B dash C dash, and here you can keep a bracket. Then use the distributive law. දැන් මතකනේ මේ normal arithmetic operations වගේ නෙමෙයි මේ ධන ලකුණ තිබ්බත් මේ distributive law එක use කරන්න පුළුවන් Boolean algebra වල. So what I'm doing here, F is equal to C plus A dash B dash and into C plus C dash. So here it is 1 again, and with the domination law you can get with the identity law you can get it here A dash B dash plus C. So now you can see how it is complex to use the Boolean algebra to get this kind of simplification. Because in this case, you can see by the Kana maps, we easily get the simplified expression. So therefore, mm, uh, you can see the Kana maps are more easy. Okay. So you can try to get this expression Boolean function by using the Boolean algebras as a homework. මේක ඔයාලා මෙන්න මේ truth table එක පාවිච්චි කරලා මෙන්න මේ sum of products සහ Boolean algebra එක use කරලා මේක simplify කරන් මෙන්න මේ expression එක ගන්න. There are many methods. So you can you have to follow the rules, but there are many ways that you can get that expression. ඔන්න ඔය expression එක ගන්න ඔයාලට එක එක path තියෙන පුළුවන්. ඒකට එක එක path සමහර ඒවා දිග වෙන්න පුළුවන්, සමහර ඒවා කෙටි වෙන්න පුළුවන්. But the Kana map is the most the easiest path that you can have it. දැන් Kana map එක බලලා මේක ලියන්න පුරුදු වෙලා තිබ්බනම් මේක ලේසියෙන්ම ගන්න පුළුවන්. හැබැයි මේ දැන් අර ආන්සර් දීපු එකනත් එහෙම කෙලින්ම එකපාර අරන් තමයි තිබ්බේ. මම උනට මේ අපි Kana map එක අඳින්න නැතුව කොහොමද එක්ස්ප්‍රෙෂන්ස් විතරක් තියෙද්දි අපිට පේන පාත් එක අනුව තමයි මම මේ ගියේ. That's why I try to do it before the Kana maps. මම K maps වල කලින් මේක අඳින්න හැදුවෙත් ඒක හින්දා. Now not so problem. But now we know how you can use the Boolean expressions in simplification, do Boolean algebra in simplification, and you can identify the Kana maps is the more simple method for this. හරි. Kana map එක ගත්ත විදිය තේරිච්ච නැති කට්ටිය ඉන්නවා පොඩක් කියන්න. Seems all of you get it. Okay, now in this question that you can see, there is another part, draw the corresponding logic circuit. So the truth tables of the logic gates. So this is just simple that you have to use those truth tables. So use those logic gates to draw the logic circuit. Okay. So I will erase this Boolean algebra part, simplification parts, and draw the logic circuit now. Let's see how I can draw the logic circuit. So the Boolean function that I got is a dash b dash plus c. So now you can see the main. So there are three inputs, A, B, and C. So when I'm drawing it, first I will consider these two terms, A dash, B dash plus C. That means A dash and B dash. That means complement of A. You can say complement of A and complement of B is a one term and the other term is C. And these two terms are combined with O gate. So therefore, first draw an O gate. And this gives the output. And one input is C and other input is the complement of A and complement of B. So just this C and there can be A and B. So you can see A and B, these are not A and B, these are the complement of A and the complement of B. So there you can see two NOT gates. Then what's here? A comes as the input, but from the NOT gate, you get the complement of A. And here to the NOT gate, the input is B and the output is the complement of B. So now we have complement of A and the complement of B. And those are connected with AND gate. It's product. Product means AND gate. So therefore use the AND gate here. So then keep these inputs to AND gate and then connect it to the OR gate. So this is how you can draw the corresponding logic circuit. So I think you can practice them with the truth tables of logic gates. And these are the things that you should know. හරි මේ ටික තමයි දැන් ඔයාලා දැනගන්න ඕන කොටස් ටික. මට මේ දැන් කාන මැප්ස් කොටසයි මේ කොරස්පොන්ඩින් ලොජික් ගේට් එක අඳින කොටසයි තේරිච්ච නැති කට්ටිය ඉන්නවනම් පොඩ්ඩක් කියන්න. Actually you can try it. මේක ෆොටෝ එකක් හරි ඔයාලා ගහලා තියාගන්න මේ දහලා මේ you can try it and I will send you some problems then you can try it. මම මේක පොඩි problems ටික share කරන්න. Then you can try it and actually it is really key to practice these things. මේ set එක practice කරන එක වැදගත් because these are you have to understand these things not to by heart these things. يعني අර පාඩම් කරලා කරන එක නෙමේ practice කරන දේවල්. ඒකින්ද I will send you some problems then you can practice them. Okay, so please let me know if you have a problem, any issue, please raise your hand. මේ සම්බන්ධ දැනගන්න මොනවද දේවල් තියෙනවා නම් පොඩක් අත උස්සන්න. If not, I will conclude today's lecture and I will send you a message how is the structure of the paper. Paper structure එක මොකක්ද කියලා මම ඔයාලට විස්තරාත්මක message එකක් එවන්නම්. So normally in from my part it is 10 MCQs and 3 essay questions. So the MCQs are from all the parts that I have done. That mean signal conditioning parts of PAMP and as well as from the sensor part and the sensors and the actuator part and from this one, the Karnaugh map and Boolean algebra part. And as well as there are 3 essay questions. One is from this part Boolean algebra and Karnaugh maps. And one question will be from the sensors and actuators, and other one is from the op-amp. You can now you know about the structure of the applied electronic parts. That is from my side, but then there will be another 10 MCQs and 3 essay questions from uh, the parts that is done by the Ushamis. Therefore, totally that you have to face for 20 MCQs and 6 essay questions. And actually, I will send you a written message. Then you can refer it before the exam. Then you can understand what you have to do in the exam. Okay. So this is for today. And thank you for joining the lecture, even it's late night. Uh, and okay, thank you all, and wish you all the best for your exams. And I will send you some problems to practice. Okay. Good night, you. I will end the meeting now.
Good night, sir.